Today we're going to learn about standard error. So if you could pause the video and go to Schoology and download the Excel regression example, then you can follow along with the video and fill in this information. Okay, so here we go. This is the same data that we did in the last lesson, except for, if you notice, I've added two new columns. Y-cap and the difference of y minus y-cap squared. We need this information to calculate standard error. All right, now what is y-cap? All right, our data here are input and output. If you were to plot it, it would be a scatter plot. And if we were to draw a line of best fit through it and then figured out what the equation was for that line of best fit, we would have our linear equation. So let's do that first. All right, so first correlation, we're going to do an equal correl parentheses. We can do all our x's followed by a comma, then highlight all your y's, close it off with the parentheses, and press enter. So our correlation is 0.88. So our data is very correlated. All right. So now to find our linear equation, we need slope. So in slope, I'm going to do equal, type in the word slope, parentheses. Now the only difference here is we highlight the y's first, followed by a comma, and then highlight all the x's. Close it with parentheses and press enter. So our slope is 196.15. Now we need our y-intercept, which is b. Our equation is going to be y equals mx plus b. So here we go. Equal intercept, parentheses. Once again, you highlight the y's first, followed by a comma, highlight the x's, close your parenthesis, press enter. So our y-intercept is 102.29. So I'm going to come down here, I'm going to write my equation. Y equals 196.15x plus 102.29. So that's my linear equation. So this y right here, which I'm going to change, I'm going to call this y-cap. So y-cap is calculated using our linear equation. So these are all the data, all the points that make up that straight line that goes through our scatter plot. So we need to know for this x, what would be the y value on the line, which is the y-cap. So what we're going to do is we're going to write an equation right here in C2 that will calculate y-cap. All right, so follow along. I'll go real slow. So in C2, go equal, then we're going to do 196.15 times, which is shift 8. Then we want x, but we're going to do a dynamic x. We're going to click A2. Then we're going to add to this our y-intercept, which is 102.29. 0.29. Press enter, and there is our y-cap for an x of 1.6. Now we're going to do the same thing for all these cells here. But there's an easier way of doing it in Excel. So click on C2. Right now my cursor is a white plus sign. We want to go to the bottom right corner and it turns into a black plus sign. Left click your cursor and drag it down, and it'll calculate all of your y-caps that go with the corresponding x's. Now if I were to click on C3, notice it's now A3. If I click on C4, notice it's now A4. So that's why we do it that way, so Excel will capture the next associated x value. Now we also need the square of the difference between y and y-cap. So let's, in D2, what we're going to do is we're going to do equals a parentheses. Now we're going to do it dynamic again, so we can do that trick where we drag down and it makes all these all the calculations for us. You're going to collect B2 minus C2. You're going to close the parentheses. You're going to do the little chevron, which is shift number 6, shift 6, and then 2. So it's B2 minus C2 squared. The chevron is an exponent symbol in Excel. Press enter, and my difference squared for the first point of x of 1.6 is 145.6849. Now highlight D2. Notice my cursor is a white plus sign. I'm going to go to the bottom right corner until it turns into a black plus sign. I'm going to left click my mouse, drag it down, and let go, and now it's calculated all my differences squared. Now what I need is the sum of this column. So whichever Excel you're using, you look for this sigma sign. Look over here. It's sigma means sum. It's a Greek symbol for sum. I'm going to click on there, or you could do equals sum and then highlight all things. So now I'm going to push return. It added up everything from D2 all the way down to D11. So there is my sum. All right, there's one more thing. There's a couple more things we need, because SE is our standard error. And our standard error is the sum divided by the degrees of freedom raised to the 1/2 power, which means you're taking the square root. Now, degrees of freedom is defined by how many elements you have, which is n, minus 2. So degrees of freedom n minus 2. All right? So we need n. N in this count is count. So right here we're going to do equals, put in the word count, put a parentheses. Now, we only need to do x's or we need to do y's. We don't need to do both. We just need to do one. So I'm going to highlight just the x column. I'm going to close my parentheses and press enter. And there are 10 elements, 10 data points. So my degree of freedom is 8, because 10 minus 2 is 8. So now I'm going to calculate my standard error. In H5, I'm going to put an equal sign. I'm going to put a parentheses. I'm going to click on my sum, which is D12, and then I'm going to divide by. Now, you could either put in the formula 10 minus 2, or you could do mental math, and 10 minus 2 is 8. Divide. Then we're going to go get our chevron, which is shift 6, and we're going to do 0.5. That is taking the square root, and press enter. So in this case, our standard error of our data is 138.26. Now you are going to try this same technique with your data set that's in the assignment.